Hello everyone, this is our video solution to problem 4 from Superquiz 2. This is the first of 3 consecutive problems that are going to consider the connection between unit step functions, piecewise defined functions, and their graphs. So in this one we're given a function in terms of unit step functions. So useful to recall here that when we write u c of t, this is actually a piecewise defined function. It's defined to be 0 when t is less than c, and 1 when t is greater than or equal to c. All right, so here, let's take a look. So in this problem, we are given it as a combination of unit step functions, and we want to rewrite this as a piecewise defined function, and then we want to graph it. So let's try to do this as a piecewise defined function. So we notice that it's going to start at 4. So whenever you have something written in terms of unit step functions, and then you have something which doesn't have a unit step function, that's basically where it started, right? So it's going to start at 4. And where is it going to do any sort of a change? Well, these numbers tell you, right? There's going to be some sort of a switch at 0 and at 4. So we're going to be able to put in here some domain switches. So t from negative infinity to 0, it's going to be 4. And then at 0, something is going to happen, and we'll figure out what happens. And it's going to stay that way until we get to 4. Okay, and then at 4, something else happens, and that, well, there's nothing else, right? So it'll just stay that way for eternity. Okay, so what does happen at 0? Well, it was at 4, but now you're going to, well, there's a minus t. So u0 would say, okay, you stay at nothing until you get to 0, and then at 0, you're going to go up to 1. But in this case, it'll be going down by t, right? Because you're multiplying minus t by this 1. So it was at 4, but now we're going to go down by t. And what happens when we get to u4? Well, it goes up by the square root of t. So we had 4 minus t, now it'll be 4 minus t plus the square root of t. All right, so we've written this as a piecewise defined function. What's the graph look like? Well, let's see here. Let's get a nice graph going. This is going to be our f of t. Here we have a t. All right, so the special points are going to be at 0, right? There's 0 and say at 4. Now we know before we get to 0, it's just at a constant height of 4. So let's put that over here. That can be a 4. And it just looks like this. And then we get a nice hole at 4. All right, now what happens then? It turns into 4 minus t. Well, this is a line. It has y-intercept 4. Ooh, it actually, we get to fill in that dot. And then it's going to have slope -1. Okay, now it's going to have that all the way till we get to 4. At 4, well, 4 minus 4 is 0. It's going to hit the axis. So we just get this straight line. Right, oh, and let's make it an open dot until we know otherwise. Okay, now what happens at this point? Now you're going to start adding on the square root of t. The square root of t, that's one of those graphs that looks, kind of like that. So let's see how that's going to fit into this. So at t equals 4, we had 4 minus 4 is 0, plus the square root of 4, that would be 2. Okay, so it's going to start actually up here at 2. All right, and I don't know, maybe we can sort of guess what it's doing a little bit. So remember we just said that when we put in t equals 4, this first part was 0. Now as t grows, this is going to be getting negative, and the root t is going to be positive. But linear is going to beat square root. So this graph is going to have to go down. All right, that linear piece is just too strong, and this thing's gonna have to go down. Now, it's not like immediately clear where it's going to hit, all right? But we know it's gonna come down, maybe something like that. And if I had to guess, what precisely that point was, I guess I would guess something like 9 plus the square root of 17 over 2. Okay, that's just a joke, all right? Like, that actually is the answer, but how did I get that? It wasn't a guess, right? You solved this for 0. I wouldn't, of course, expect you to be doing this on an exam, like you have more important things to be doing with your time. But okay, if you wanted to know where it crossed, you certainly could do it, right? Setting that equal to 0. All right. There we go. We converted this combination of unit step functions both into a piecewise function as well as into a graph. Not too bad. All right. Next time, we'll mix it up.